इतिहास में हम सभी ने पढ़ा है, हिमालय हमारी सीमाओं का रक्षक है। पर क्या यह रक्षक सिर्फ रक्षा तक ही सीमित है? नहीं, यही प्रहरी गंगा, यमुना, ब्रह्मपुत्र जैसी कई जीवनदायी नदियों का उद्गम स्थल भी है। यह नदियां न सिर्फ देश के कई राज्यों की प्यास बुझाती है, बल्कि पर्यटन के साथ कई छोटे बड़े उद्योगों की आवश्यकताओं को भी पूरा करती है। पश्चिमी हिमालय क्षेत्र जो जम्मू कश्मीर, हिमाचल प्रदेश, उत्तराखंड राज्यों से लगता है, तो वहीं पूर्वी क्षेत्र पूर्वोत्तर के 7 राज्यों के साथ एक बहुत बड़े जनसमूह को अविरल और निर्मल नदियों की धारा से एक बेहतर जीवन स्तर प्रदान करता है। यही हिमालय कई धर्म संप्रदाय के लोगों की आस्था का केंद्र भी है। हिमालय की प्राकृतिक संपदा की बात करें तो इसकी उपजाऊ मिट्टी को किसान अपनी मेहनत से सींचकर अनाज, फल, सब्जी उगाकर देश का पेट भरते हैं। तो वहीं दूसरी ओर है हमारे वन क्षेत्र, जो विभिन्न प्रजातियों के जीव जंतुओं का आश्रय स्थल तो है ही, साथ ही साथ प्राणवायु का बहुत बड़ा स्रोत भी है। यही वन हमारे देश में लकड़ी व उससे बने सह उत्पादों की मांग को भी पूरा करते हैं। साथ ही औषधीय गुणों वाली अथाह वनस्पति भी खुद में समेटे हुए है और ऐसे कई पुष्पों और वनस्पति का उद्गम स्थल भी है, जो पूरे विश्व में सिर्फ भारतीय हिमालय क्षेत्र में पाई जाती है। हर वर्ष गर्मियों में पिघल जाने वाली बर्फ की पुनः पूर्ति के लिए हिमालयी ग्लेशियर बर्फबारी पर निर्भर करते हैं। लेकिन ग्लोबल वार्मिंग ने हिमालय क्षेत्र के पारिस्थितिकी तंत्र पर नकारात्मक प्रभाव डाला है। जिसमें कि बर्फ का असमय ही पिघल जाना, बादल का फटना, हिमस्खलन जैसी कई चुनौतियां हैं, जिसका सामना क्षेत्र में ऊंचाई पर रहने वाले लोगों को करना पड़ता है। कई बार बर्फ तेजी से पिघलने लगती है और अस्थायी रूप से पहाड़ों पर जमा हो जाती है। जब क्षमता से अधिक जल जमाव हो जाता है तो झील टूट जाती है और अपने साथ विनाशकारी बाढ़ लाती है, जिसे तकनीकी भाषा में ग्लफ कहते हैं। नीति आयोग के अनुसार क्षेत्र में सिर्फ पर्यटन के कारण 23,000 टन कचरा प्रतिदिन उत्पन्न होता है, जो क्षेत्र के झरनों, तालाबों, नदियों के प्रदूषण का एक बहुत बड़ा कारण है। साथ ही अंधाधुंध शहरीकरण के कारण यह क्षेत्र कंक्रीट के जंगलों में बदलता जा रहा है। निर्माण कार्य से जुड़ा लाखों टन मलबा भी इन्हीं नदियों में बहा दिया जाता है, जिससे अविरल नदियों के प्रवाह अब अवरुद्ध होने लगे हैं। वनों की कटाई भी एक बहुत बड़ा कारण है, जिससे हिमालयी पारिस्थितिकी तंत्र प्रभावित हुआ है और पहाड़ों पर पानी ठहरने की प्रक्रिया भी बाधित हुई है। ग्लोबल वार्मिंग के हिमालय पर प्रभाव दशकों पुराने हैं, किंतु आज विज्ञात 9,500 से अधिक ग्लेशियरों में से मात्र 100 भी ऐसे नहीं हैं जिनके आंकड़े उपलब्ध हो। राहत की बात तो यह है कि अधिकांश ग्लेशियर आज भी मानवीय गतिविधियों से अछूते हैं, किंतु सवाल ये है, कब तक? हिमालय क्षेत्र में जलवायु परिवर्तन की समस्या एवं संसाधनों के अनुचित दोहन के लिए हम भी बराबर की जिम्मेदार हैं। इसलिए हम पर समाधान की जिम्मेदारी भी है। भारत सरकार द्वारा हिमालय व इसके संपूर्ण पारिस्थितिकीय तंत्र के संरक्षण के लिए कई कार्यक्रम चलाए गए हैं, जिनमें प्रमुख हैं नीति आयोग द्वारा हिमालय क्षेत्र में सतत विकास के लिए योगदान, पर्यावरण, वन एवं जलवायु परिवर्तन मंत्रालय द्वारा वित्त पोषित राष्ट्रीय हिमालय अध्ययन मिशन, विज्ञान एवं प्रौद्योगिकी मंत्रालय द्वारा वित्त पोषित राष्ट्रीय सतत हिमालय पारिस्थितिकीय तंत्र विकास मिशन। सरकारी प्रयासों के अलावा भी संयुक्त राष्ट्र द्वारा सुझाए गए सतत विकास के लक्ष्यों में से एक जल सुरक्षा को प्राप्त करने के लिए श्री सेवांग नूरफेल द्वारा लद्दाख में कृत्रिम ग्लेशियर का निर्माण तथा श्री सोनम वांगचुक द्वारा हिम स्तूप का निर्माण करने जैसी कई अनुकरणीय पहल भी की गई है, जो हमें स्थानीय आवश्यकताओं व उनकी प्रतिपूर्ति हेतु स्थानीय विकल्पों के बारे में ज्ञान देती है। इसके अलावा जल शक्ति मंत्रालय द्वारा जल जीवन मिशन भी ग्राम स्तर पर जल सुरक्षा के लिए एक महत्वाकांक्षी परियोजना है। नीति आयोग के अनुसार भारतीय हिमालय क्षेत्र में पर्यटन से 23,000 टन ठोस कचरा प्रतिदिन इकट्ठा होता है और अनुमान के मुताबिक पर्यटकों की संख्या 2025 तक बढ़कर दोगुनी हो जाएगी। भारतीय हिमालय क्षेत्र से 40 लाख झरने बहते हैं, जिनका संरक्षण क्षेत्र की जल सुरक्षा के लिए अति महत्वपूर्ण है। देश के उत्तर पूर्वी पहाड़ी क्षेत्रों में कुशल कारीगरों की कमी को पूरा कर क्षेत्र में खाद्य सुरक्षा व बेहतर पोषण सुनिश्चित किया जा सकता है। भारतीय हिमालय क्षेत्र में 12 जिले ऐसे हैं जिन पर प्राथमिकता से ध्यान देना आवश्यक है। भूजल संरक्षण के लिए झरनों के उद्गम का मूल्यांकन भी क्षेत्र में जल सुरक्षा सुनिश्चित करने हेतु एक प्रभावी उपाय है। एक बहुत बड़ी आबादी जो हिमालय क्षेत्र को छोड़कर रोजगार की तलाश में पलायन कर गई थी, कोरोना काल में आज वापस लौट रही है। स्वास्थ्य के प्रति बड़ी जागरूकता के कारण पेशेवर लोगों का एक बहुत बड़ा समूह भी वापस हिमालय क्षेत्र की ओर रुख किए हुए है, जो अब जैविक खेती के रूप में इस क्षेत्र में भविष्य की संभावनाओं को तलाश रहा है। कोरोना काल ने हिमालय के पारिस्थितिकी तंत्र को एक नई स्फूर्ति दी है और हमें एक नई सोच, चुनौती को अवसर में बदलने की, या यूं कहें प्रकृति ने हमें नए सिरे से अवसर दिया है और साथ ही सवाल भी किया है। क्या हिमालय में पर्यावरण तथा प्राकृतिक संपदा के संरक्षण के लिए हम रोजगार की उचित तकनीकी कार्य योजनाओं का निर्माण कर पाने में सक्षम हैं? क्या हर हाथ को काम देने की योजनाओं की नीतियों के क्रियान्वयन में उचित विज्ञान तथा तकनीक के मिश्रण से हिमालय क्षेत्र की तस्वीर को बदला जा सकता है? क्या हिमालय की ओर रुख करने वाले पेशेवर लोगों के अनुभवों का सही उपयोग लिया जा सकता है? क्या हम एक ऐसी पर्यटन नीति विकसित कर पाने में सक्षम हैं जिससे क्षेत्र में पर्यटन तो बढ़े ही साथ पर्यटन स्थल की पारिस्थितिकीय वहन क्षमता के अनुसार पर्यटकों की आवाजाही को नियंत्रित किया जा सके, जिससे पर्यटक भी प्राकृतिक संसाधनों के संरक्षण के प्रति अधिक उत्तरदायी बन सके। प्रकृति का हमसे सबसे बड़ा सवाल है। कोरोना काल की चुनौती के समय भारतीय हिमालयी क्षेत्र के संरक्षण का जो सुअवसर हमें प्राप्त हुआ है, क्या हम इस चुनौती को अवसर में बदल पाएंगे? आइए विज्ञान एवं प्रौद्योगिकी के प्रभावी उपाय से आप और हम मिलकर एक बेहतर कल के लिए हिमालय क्षेत्र के संरक्षण हेतु कार्य करें, जिससे सुरक्षित रह सके हमारे जन, जल, जंगल और जमीन।
So now I request the next presentation. We are starting the presentation. This presentation is on snow, glacier and globe studies in the Himalayas by Dr. Sanjay Jain.
Okay, thank you, Dr. Inos.
मैं इसको फिर ऐसा करता हूँ, मैं इसको निकलवा के
पांडे जी अपना जरा सा माइक्रोफोन म्यूट कर दीजिए।
हाँ, तो मैं असल में क्या है उस समय जब आपका वो मेरे को क्या हो गया था, बुखार हो गया था 1 महीने के लिए।
पांडे जी
तो उसमें मैं हॉस्पिटलाइज हो गया, उसी बीच टाइम निकल गया वो।
So please everybody mute their videos.
पांडे जी प्लीज म्यूट योर माइक्रोफोन। आरपी पांडे जी।
हाँ, जरा दाऊ साहब से मैं प्रणाम तो कर ही लेता हूँ जी।
ओके, गुड आफ्टरनून टू एवरीबॉडी एंड सभी को हिमालय दिवस की बहुत बहुत शुभकामनाएं। मैं यहाँ पर प्रेजेंट करने जा रहा हूँ स्नो ग्लेशियर और ब्लॉक स्टडीज जो कि हिमालय में की हैं। कुछ जनरल बातें होंगी और कुछ जो NIH में स्टडीज चल रही है उनके बारे में। So first slide is Himalayan water resources, and all of us know that Himalayan rivers are so important for our country. So if we see the high mountain area around the world have served as important source for fresh water for the population living in the lowland areas. And if we see the Himalayan mountain, it is one of the largest mountain chains serving as the fresh water resource. And number of major rivers are there in this particular Himalayan region. About 35% of the geographical area is covered by mountains in our country, and out of which 58% is accounted for by the mighty Himalayas, in which we have more than 5,000 glaciers covering about 38,000 square kilometer area. We have number of river systems in the Himalayan region. In our country also we have three major river systems, Indus, Brahmaputra and Ganga, originating from Himalayan region. So we have to have the seasonal snow and glacier melt coming from the Himalayan river as the dependable source of water for irrigation, hydroelectric power and drinking water supply, and the use of new technology, techniques and models important for monitoring snow and glacier fields. If we see the Indian Himalayan region, so this is the geographical area. We have Western Himalayan region and Eastern Himalayan region, Central Himalayan region. So the number of states are covered under Himalayan region. So there are a number of research questions if we are talking about the study of hydrological problems in the Himalayan region. How much glacial water is stored in Himalaya? Would successive prolonged summers melt glacier alarmingly? That is one of the major questions we are seeing in number of parliamentary questions also. This is one of the major or important part. Why are some glaciers in the region of India retreating or advancing? Why is glacier mass balance positive or negative for glaciers in the similar regions? What is the proportion of ice snow water? That is again very important. We know that we are getting snow and ice melt in the Himalayan basins. And would glacier retreat at lower elevation have minimal effect on downstream? And how is the future glacier evolution or runoff projections vis-a-vis of climate change and glacier change? So there are some of the consequences in the Himalayan region which we can see here. That is one of the point is the water scarcity or security, food scarcity or security, even energy security. So today we are celebrating this Himalayan Day, and in this we have kept the theme of water security in the Himalayan region. Rise in natural hazards we have seen, and one or two presentations we will see during the day. Himalayan desertification, retreating glaciers which are destabilizing the slopes. Hydropower may suffer, increased vulnerability in the downstream area, extreme runoff events, or forced migration to the plains, and then increase in glacier lake outburst flood. So keeping in view this, there are a number of key water issues which I am presenting here in this slide, and on some of the aspects we are working here in NIH. First is the assessment of snow, glacier melt runoff, then impact of climate change on the regional water resources. That is one of the major issues. Then changing glacier resources, flash flood generated from cloud burst and runoff, excessive soil erosion and siltation in river flows, conservation and management of lakes and springs, and then one of the major problems which we have seen, we are applying number of models, that is the hydrological network and databases. In the higher altitude of Himalayan region, we don't have much of the network. So now in NIH, we are working in these four areas. First is Himalayan glaciers and hydrology field monitoring. We are working on this for the last 20 years. Then snow, glacier melt runoff, modeling and impact of climate change. Then mass balance, glacier change, and again impact on runoff. And finally, glacier lake outburst flood for hydropower projects. I would like to mention here also that we are working also on the springs, which will be presented today by Dr. Rawat, as well as we are having one of the major projects sponsored by DST, and in the next presentation, Dr. INC-Inter-governmental will present number of studies which we have taken up under that NMC project of DST. So coming to the studies which we are carrying out in NIH. First one is the Himalayan glacier and hydrology field monitoring that is generating research grade data for a data scarce region. So number one is Gangotri Glacier. This is a project sponsored by DST earlier in year 2000, and since then we have a meteorological observatory at Purvas. And then AWS has been installed at the same site in 2009. So we are collecting data as well as we are analyzing that data for a number of years. Then another project which has been taken up in at NIH is the Henwell project. This is a research work station which has been taken care of by the scientists of water resources system division like Dr. Manish Nima, Dr. Manoj, and Dr. P.K. Mishra. So this is a project in which we have installed number of stations, that is discharge stations, AWS, eddy covariance, flux measurement unit, Cosmos, soil moisture monitoring system. So number of instrumentation have been carried out at this particular location. The third one, which is again a very ambitious project in Ladakh region, it was sponsored by SAR DST. And in this, Dr. Manoj is studying the three cryospheric elements, that is glacier, snow, and permafrost. And recently, a project on permafrost has been awarded under NMHS. The last one is the temperature monitoring in the Western Himalayan region. That also is a project under NMHS. And in this project, 40 temperature and humidity stations across Himalaya, Western Himalaya, have been installed and they have been monitored. So these are the four major field-based studies which we are carrying out. Then coming to the snow and glacier melt runoff modeling, number of studies for mainly four basins have been carried out. That's and Chenab basins, and we have completed earlier that a sufficient amount of snow and glacier melt runoff is coming from these rivers. Like if you can see at Satluj at Agra, about 50 and about 60% on an average snow glacier melt runoff we are getting. Similarly at Pandu, Vyas basin, then now at Akun, so and Ganga at Gimple. So we are getting sufficient amount from these snow and glacier melt runoff at different sites. For that purpose, a model has been developed at NIT that is called a snow mode model. We have carried out number of studies using this model, and on the left side you can see that in this type of modeling we have to consider rain, snow and rain, and then snow and glacier on the top. So we can divide the whole basin into three parts. One is rain-fed basin, snow-fed basin, and glacier-fed basin. And on the basis of that, that snow mode model has been developed. Beside this snow mode model, SWAT and WIC model have also been used for a number of studies. And recently, SPHY model that also has been used for snow and glacier melt runoff model. So we are using different models to carry out snow and glacier melt runoff for different basins. On the bottom side, I am showing you the Satluj basin and the snow cover area, which has been made by different satellites. So we have to generate the snow cover maps, and then on the basis of that and using the different inputs in that particular model, we have to write the snow and glacier melt runoff. So in this slide, I will just briefly tell some of the outcome of the study, that rate, volume, and timing of snow melt are likely to change with the climate change, because some of the studies have been carried out to see the impact of climate change. And reduced snow melt from lower elevations is partially counteracted from higher elevations, that is from glacier melt. In Satluj basin, if you are talking that increase in stream flow, we have seen 11 to 19% from the current average annual flow in upper Satluj basin, that is the Rampur side, with RCP 4.5. Similarly, in Vyas basin, some hypothetical scenarios have been applied, as well as some of the temperature change have been applied, and we have seen that 9 to 8.69% with the rise of 1 to 2 degrees. In NMC, we are carrying out a number of studies for Upper Ganga basin. So the finding of that is snow cover in Upper Ganga decreasing in December and June and in June and July increasing trend in higher elevations. In higher elevations, we are getting snow in these months also. The stream flow decreases in average rainfall and monsoon in Satluj, decrease in Vyas, peak flow increasing in Satluj and Vyas, increasing trend in Chenab, and initially increased as glacier melt, then decreases when glaciers are depleted. So that has been seen in this Chenab basin. Then the next part of this cryospheric study is the glacier change and retreat. we know that there are a number of thousands of glaciers in these three basins. A report has been prepared by ISRO and MOEF in 2011. And as per that report, most of the glaciers which have been monitored so far, like 2,700 glaciers, 2,180 glaciers, 54 glaciers are retreating and some are advancing, while 148 glaciers show no change. So this is a finding of MOEF. So we have also carried out number of studies to see the glacier change in different basins. In Baspa basin of Satluj, for example, if we see number of glaciers have been lost. In 2018 data, if we have used, then 84 glaciers with an area of 174.0 square kilometer we have found. In 2011, 107 glaciers, and from 1976, from 76 data we have taken from survey from the Fukushi, we have found that about 23.3% of the glacier have been lost in this particular Baspa basin. We had analyzed that southwest and south-facing glaciers, the loss is very high. The small glaciers and at low altitude, the glaciers are losing much and retreating more. So the glaciers, they are small in size and at lower altitude because of the rise in temperature. We have correlated our findings with the temperature and other data also. We have seen that the temperature is rising. We are having the data of BBMP in this particular basin. Similarly, a study has been carried out for Gangotri Glacier, which is one of the major glacier, and we are monitoring this for the last 20 years. And in this glacier also, we have seen that this glacier is retreating at a rate of 17 to 80 meter per year. And on the right side, you can see the area vacated by this glacier shown in the light blue color. On the top, this is, as I have said, we are carrying out an INC project, but they will be presented by Dr. Goyal. But here I can share this, the Upper Ganga Basin, the glaciers in 1990, 2000 and 2014. The area is decreasing and number of glaciers are decreasing in this particular, in this catchment also. Then the next topic, which the area which we are dealing here is the glacial lake and glacial lake outburst flood. So, as you know that glacier dam lakes are formed by accumulation of water from the melting of snow and ice cover and by blockage of end moraines. This is one of the major glacial lakes which can breach any time. So, a glacial lake outburst flood can occur when a lake contained by a glacier or a terminal moraine dam fails. So the bursting of moraine dam lake is often due to the breaching of the dam by the erosion of the dam material as a result of overtopping by surging water or piping of dam material. In 2013, we have seen a major event in our Uttarakhand state. You know that there was a Kedarnath tragedy, and during that time we have seen that heavy precipitation was one of the reasons, as well as the breaching of Chakrabari Lake. Though this lake was not vulnerable, but it was breached due to the heavy rainfall as well as due to the smaller tank in that particular lake. And on the right side, you can see after the blow-off, this was the situation of Kedarnath town. Last year, we have also visited because we had a meeting with Uttarakhand Minister, Mr. Satpal Maharaj, and there they told that it was came to know that the lake is again started filling and other things which were there after that blow-off event. So we have visited that, and in the bottom side you can see that now the lake is empty, and you can see also the site from where it reached. And on the left side I have shown before the event. This is the Google Earth image. On the right side after the event. So it is clearly seen that lake was breached, and at present also there is no water in that lake, and a small stream is there only. So that has been shown on the right side. So on this topic, we received a number of requests from different agencies, and we have carried out a number of studies for Eastern and Western Himalaya. The flood values at lake site as well as hydropower project site, because in addition to the benign flood, which the hydropower projects companies are taking, they have to consider the water which is coming due to the reaching of that particular lake. So we have received number of requests on THDC, NHPC, and some of the private agencies also. We have carried out number of studies in Western Himalaya as well as in Eastern Himalaya. In Western Himalaya, we have received two requests from THDC, that is for Roorkee project and project. We have carried out a study for that. From NHPC for Kwang project in Himachal, Chamkarchu and Kori, they are in Bhutan. Actually, NHPC is having these projects in the Bhutan area. Then Lachung also from one of the private company we received, and we did that study in Sikkim. In Baspa Basin, in Satluj, JSW Energy Limited, they have given us a project. And recently we have been awarded a project under NMHS, that is for Tista Basin. So the whole Tista Basin is being studied for snow and glacier melt runoff as well as glacier change and for bluff study. So on the lower side, I am just showing you one of the lake which is there in Chamkarchu Basin of Bhutan, which is a vulnerable lake, and the lake you can see is increasing over the years. And if we see through satellite data, it has increased 3 times over the years. So it is one of the major vulnerable lake which has been studied for bluff study. The guideline for preparation of guidelines for the management of glacier hazards, and this especially glacial lake outburst floods, these are under preparation by NDMA, and NDMA has given this task to NIH as a nodal agency to there is a task force, and NIH is also a member of that task force, and under that guideline, this project by NDMA, this task has to be completed by NIH, and they are almost ready with the help of the stakeholders as well as from the task force members. Task force members are from different organizations working in this particular area, and it is planned to release these guidelines in this month. So, and this is just an example which we have carried out, taking the hydrodynamic modeling and the identification of vulnerable lakes. Like here, I'm showing you for the Chamkarchu hydroelectric project of Bhutan area, and this is the lake, which is a vulnerable lake, and then cross sections have been drawn at the downstream of the project site, and then it was simulated by the hydrodynamic model at the project site, how much flood or discharge we will get, and after how much time that has been given to this NHPC. So this is just an example. So similarly, we have carried out these kind of study for number of projects. So this is in brief about the studies which we are carrying out. This is just a concluding remark I am giving here, that snow and glacier melting now have a major contribution to the river flows, which we have seen in a number of studies. So it is necessary to characterize the glaciers in different climatological regions of the basin. To keep this in mind, we have taken up one study, and we have submitted one project to MOES, in which the glaciers of the 4 basins will be studied, and the impact of glacier change and runoff, and also the change of climate change will be studied. The rate, volume, and timing of snow glacier melt are likely to change. This is one of the area in which we have to work. Therefore, impact of climate change on the snow melt runoff and total stream flow of the large Himalayan rivers should be investigated using a number of climate models are available now. So the output of those climate models we have to take as the input to the calibrated hydrological models to see the impact of climate change. Then studies on the trend of changes in snow cover over the Himalayan basins. We have to study how that snow cover is changing or glaciers are changing and all that we have to study. Then finally, climate warming especially will increase the frequency and risk of droughts that we have to consider. The regular mapping and monitoring of lakes are needed. At present, CWC and NRSC is also doing this study, and number of reports they have published to map the lakes and to monitor the lakes. We have identified the potentially dangerous lakes, which we have done in these 4 basins of Satluj, Bias, Chenab, and Ganga under an MC project. And we have mapped the glaciers over time, regular time interval, as well as the lakes. And we have identified number of lakes which are vulnerable in these 4 basins, and we did mapping of these lakes. Another area is we have to monitor the potentially dangerous lakes. Of course, NIC or NDMA, they have also made a project under this after this guideline, they have projected a comprehensive project to monitor the potentially dangerous lakes. So high resolution fine series satellite data, they are very useful for this purpose, and we have to take appropriate measures to reduce the potential risk from these lakes, like early warning system and all that. They are part of those guidelines as well as for the comprehensive project. So this is in brief the studies which we are carrying out at NIH and the problems which we are facing in humanity. Thank you. If there is any question, Dr. Vinod or Dr. BC Goyal, or we have to go to the next presentation?
I think we will move to the next presentation, sir.
Okay, thank you.
Thank you very much, Dr. Sanjay Jain, for giving an elaborate view on snow, glacier, and globe studies in the Himalayan region, and especially which is being carried out by NIH. Now I invite Dr. M.K. Goyal. He will be speaking on hydrology of Upper Ganga Basin in climate change perspective.
Good afternoon and welcome to all the participants to this web seminar on hydrology of Himalayas. And आप सबको हिमालय डे की बहुत बहुत बधाई. And I am making a presentation on hydrology of Upper Ganga Basin in perspective of climate change. So basically, a NMC project which is sponsored by DST is being carried out at NIH since the last 5 years, and this is the last closing year of the project. And this is under the task force of water, ice, snow, including glaciers. So for this task force, DST has identified NIH as the nodal agency for carrying out this study, and we are carrying out the project on integrated hydrological studies for Upper Ganga Basin up to Rishikesh. The reason being that though DST wanted the whole of the Himalayas to be covered, but hydrological studies are generally confined in the basin perspective they are carried out. So we have taken Upper Ganga Basin as a case study for this project, as a pilot project for this study. So various hydrological aspects which are being considered in the project include, first is development of a comprehensive hydrological database of different organizations which is being collected, and development of the project website. Then real-time snow cover information system, because in hydrology and especially in Himalaya, snow cover plays an important role. So how does it vary? How does it affect the water resources in the region? So there are 11 different teams which are working on 11 different hydrological aspects of this area. And say one team is looking at the hydrological aspects, the database aspects. The another team is looking after the snow cover aspects. Now, just Dr. Sanjay Jain has mentioned about the glacial lakes and globe studies which have been carried out. So that is also one of the component of the project. Then we are also looking at the climate change perspective, how the climate is going to change in the future in the basin and how it is going to affect the water resources. So in that context, we have identified a number of hydrological models which have been calibrated for the basin, and their run for different climate scenarios are under progress. We are also looking at the aquifer interactions, say groundwater component, because that is also an important component of hydrological studies. Then as you know, that isotopes are of great use nowadays, and they can help in predicting a lot of interactions among various water resources. March, April, May, and then in the monsoon season. So June, July, August, you can say. So in these two seasons, we are finding an increasing trend of rainfall at a number of stations in the basin, whereas in post-monsoon and winter seasons, the rainfall is found to be slightly decreasing. If you look at the flows, we have also, I'm showing some graphs for the flows trends, and the discharge, you can say at the Rudraprayag at Alaknanda, that discharge seems to be increasing as far as Mandakini and Alaknanda, whereas in the Rishikesh, it is found to be slightly of the decreasing magnitude. Now, this is the trend analysis results as far as different gauging sites are concerned. So annually at Rishikesh, there is some decreasing trend in flow, whereas at Alaknanda and Mandakini, there is increasing flow. Whereas at Bhagirathi, you can say in Devprayag, when the flow is decreasing. And most of the decrease you can say is attribute here in the monsoon season, whereas at Rudraprayag, it is mostly in the monsoon season, increasing trend is observed. Now, if you look at the snow cover aspect, we have found out the snow cover extents. We have developed a methodology for discriminating between the clouds and the snow, and a semi-automatic procedure has been developed in R language for finding out the snow cover area from the MODIS 8-day snow extent maps. So using this methodology, we have computed 8-day snow cover areas in different basins, not only in Upper Ganga basin, but in different, say in Satluj, in Yamuna, in Subansiri, and various other basins of the Himalayas. We have tried to find out the snow cover. And so this, you can say, this is the MODIS snow cover area, and this is the cloud cover corrected and processed snow cover area at a particular 8-day period in the Upper Ganga basin. So these are the trends of snow cover variation in different seasons. You can say October, November, February, March, and March to June in different, you can say, basins. So in Satluj, you can say in March to June, you can see an increasing trend of snow cover, which is more or less steady in Yamuna and slightly increasing in the Upper Ganga basin. So these show the trends of occurrence of snow cover areas in different seasons. Then we have also find out in different zones, different elevation bands, what is the snow cover variation in particular years. Then we have developed a web GIS application also, in which if you select the year and the month, you can get the corresponding snow cover map. So this has been already been generated for Upper Ganga basin and the Satluj basin, and we are doing it for the other basins for which the snow cover extents have been worked out. We are also here planning so that it may be used for the planners and the modelers. We are also trying to develop a tabular presentation of these results so that one can see that in different elevation bands, how the snow cover area is varying with time. So we are going to prepare a tabular presentation of the snow cover variation, and this has been linked to our project website, which I will be demonstrating in a few times. Then we have, this is a project in which the glaciers and the glacial lakes, as Dr. Sanjayan was mentioning, has been carried out, and he is the PI of this sub-project. So glaciers have been mapped in various basins, so in Satluj basin, Chenab basin, Ganga basin, by using the Landsat data sets of different periods, starting from 1990 or 1980 onwards. So you can see this is the glacier, and they have also estimated how much is the change in the glacier, because that is a very hot topic nowadays, how the glaciers are changing in number as well as area during different years. Say from 1980, when the number of glaciers were 260 in the Bias basin, it has now increased because of various, you can say, divisions. The number has increased to 386, but the aerial extent of glaciers in Bias Basin has decreased from 587 square kilometer to 491 square kilometer. Similarly, in the Upper Ganga Basin, the number of glaciers have also decreased from in 1990 it was 315, and in 2014 it was found to be 294, and the area has decreased from 1946 to 1864 square kilometer within this duration. So all these glacier extents have been mapped in different river basins. Then glacial lake inventory has been prepared, and potentially dangerous glacial lakes have been identified. The methodology has been developed to find out the potentially dangerous glacial lakes. And you can say 3 glacial lakes in Satluj Basin, 2 lakes in Bias Basin, and 2 lakes in Chenab Basin have been identified as the potentially dangerous lakes. A criteria has been developed to specify as to which are the most vulnerable lakes. And the total number of lakes, if you see, there is quite high variation in Bias Basin as compared to Chenab and Ganga Basin. So in Ganga, you can say around 200 or 187 to be precise are the glacial lakes, while in Chenab Basin, you can say they are of the order of 89, and in Bias Basin, 14. Then the extent of glacial lakes in different basins have also been mapped for the potentially dangerous lakes, and their extents in different years have also been demarcated. Then for these lakes, the GLOF modeling studies have also been carried out, and it has been found out that if a breakage occurs, how the flood wave will move in the downstream, and corresponding hydrographs have been generated. So these are being, the different user agencies are going to be involved so that they can make use of such modeling techniques. Now, to find out the impact of snow cover and climate change on the river flows, one study has been carried out up to Maneri, which is in the upstream of Tehri and having an area of 4,200 square kilometer. And the glaciers in this basin are of the extent of 14%, while snow cover area is 82%. So in this basin, first the snow cover variability seasonally as well as in different zones have been identified. And now you see in the Upper Ganga Basin in totality, if the elevation dependent snow coverage is seen, say if up to 2000 it is zone number 1, then every 500 meter different zones have been prepared. Now if you look at different zones, say in zone, these are the different graphs of December month when you can expect very high snow cover area in the basin. But the snow cover is decreasing in zone 5, zone 4, zone 6, zone 7, 8, 9, and 10. So you can say in the month of December, we are experiencing a decreasing snowfall trend, as we had seen in the precipitation data also, that in winter season, we were experiencing a decreasing trend of precipitation in the basin. Whereas if you look at in the month of July in Upper Ganga Basin, the zone 8, zone 9, zone 10 are showing a positive trend of snow cover area, means that in the pre-monsoon and monsoon seasons, the precipitation is increasing, and in the higher elevation ranges where the precipitation is mostly in terms of snow, you are expecting a increasing trend of snow cover area in those zones. So this is corroborating what is established from the trend analysis of precipitation data. Then using different climate scenarios up to 2100, the precipitation and temperature trends have been worked out. And you can see that precipitation is found to be slightly decreasing at Deoprayag and slightly increasing at Joshimath, whereas the temperature is continuously rising. Even at Karnaprayag and Marora, you can expect a decreasing trend. So using this data, we have carried out the modeling study using the SPHY model. And we have established a correlation of 0.73 as far as the modeling results are concerned for this. So using this, using the modeling results, we have found out the contribution of glacier, snow, base flow contribution and the contribution of rain in the total flows in the Himalayas, and we feel that the snow contribution is decreasing and the rain contribution is increasing, and similarly the glacier contribution is. Though overall, we don't expect any major change in the basin runoff. Now, if you look at this, this is the historical perspective where the climate scenarios have been run with the SPY model. And you see the rainfall contribution of 18% and glacier contribution of 14%, whereas the snow contribution is of the order of 55 to 60%. But if you look at the future scenarios, which are run with the climate scenario, you see the snow contribution is going to decrease up to 44%, whereas the glacier contribution will increase and the rain contribution will also increase. Then we have calibrated different hydrological models. Earlier, we were doing it for two basins separately, Alaknanda and Bhagirathi. Then we thought of having a combined model for the complete basin, and different models as different climate scenarios are there. So different models, say VIC model, WIN-SRM, SPHY and SWAT models, these have been calibrated for the basin. And you can say these are the results for 15 years for the VIC model, and having a R square of more than 0.75. And these are the results of the WIN-SRM model. So good calibrations have been obtained as far as different models are concerned. But though the sedimentation simulation is less, which was carried out using the SWAT model. Then if you look at the different hydrological processes understanding using isotope techniques, so more than 10,000 samples have been analyzed from different 21 river gauging sites have been, river samples have been taken, 15 rainfall samples have been taken regularly at monthly time interval, and the sampling duration is from 2016 to 19. So based on this, we have computed the isotopic characteristics of the Bhagirathi and Alaknanda watershed. Now, if you see here, the contribution of Bhagirathi and Alaknanda at different time steps in the year 2016 and 17, they are of the order of 73 or 74% from Alaknanda, whereas 23 or 4% from Bhagirathi annually. Now, though in 2018, it is slightly different, 57% from Alaknanda and Bhagirathi, 42%. But their variation in different months and in different seasons have also been found out. And the groundwater contribution in winter is 40 to 50%, which decreases to 25 to 30% in pre-monsoon and 10 to 30% in monsoon. And similarly, the ice and snow contribution and surface runoff contributions have been mapped. So based on this, it has been found out that the snow and glacier melt contribution at Devprayag is of the order of 35%, whereas the groundwater contribution is 20% and rainfall contribution is 45%. And similarly, if you go to Rishikesh, slightly downstream, the rainfall contribution increases at the expense of snow and glacier melt contribution. Similarly, different contributions from different at Devprayag from Alaknanda and Bhagirathi have been developed separately, and you can see that the groundwater contribution affects a lot in the two basins. So in Bhagirathi, you can say it is 10% groundwater contribution, which increases to 25% in case of Alaknanda. Then water quality analysis has been carried out for 15 different sites in the basin, and it is established that more or less most of the parameters are within the permissible range, except TSS, total solids, suspended solids, and chemical oxygen demand. So, and these have been found to be varying. Say the chemical oxygen demand decreases, where TSS, total suspended solids, decrease as we go from upstream to downstream because of sedimentation, whereas chemical oxygen demand increases because of various industrial effluents. Similarly, the biotic species assessment has been done for the first time for this reach, and different phytoplanktons, zooplanktons, macrobenthos, and fish species have been estimated in different zones, 8 different zones, and different seasons, monsoon, winter, and this shows their variation in different months and in different zones. Similarly, environmental flows have been assessed at different project sites, and some critical reaches have been demarcated. And finally, if you look at the water census and hotspot analysis, around 200 villages have been surveyed in detail. And it has been found out what is the population in different elevation bands, what are the different water sources. So spring is found to be feeding 62% of the resources are being met from the spring resources. And then different factors for environmental degradation, various disaster affected villages have been mapped. There has been a lot of migration of the order of 65% villages, and that has also been, the reasons for that have also been corroborated. So these are some, this aspect will be presented in detail by my friend Dr. Mishra. Then these are, there is also some studies regarding the groundwater and the surface water interaction. Some piezometers have been installed, and regular monitoring is being carried out to find out the recharge from the snow areas as well as from rainfall in the groundwater regions. Then there is a very detailed analysis being carried out for a test watershed in the basin, say Hanwell and Chichili watershed, and very detailed instrumentation has been carried out in the basin. And these watersheds are being analyzed for energy flux studies, suspended sediment studies, and hydrological assessments. So finally, we have developed a web page for the project site, and one can visit that. So a number of things have been added there. What is the availability of data? You can also look at availability charts at a particular station, how much data is available. What is the data status at each point? Then you can also find out in different months how much rainfall has been reported. We are also trying to link the various spatial data which is coming in real time in the basin. So these are some of the aspects of the project. And finally, now after all the models will be calibrated, we will carry out an integration of inputs from all the sub-projects so as to finally come out with the plan for how the climate change assessment should be addressed, and how the modeling results are telling about the future flows and how to tackle them, what could be the various adaptation scenarios that could be adopted for the basin. Thank you very much.
Yeah.
Thank you, Dr. Goyal, for giving an elaborate description about what we are doing under NMC project and how we are contributing to the new knowledge generation in the Himalayan region. Now, so the next presentation is on insights on cloudburst and permafrost in the Indian Himalayan region. I will make the presentation on this topic. Good afternoon to everyone. I'm Dr. Rinoj Thayen of National Institute of Hydrology. I'll be speaking on emerging insights on cloudburst and permafrost in the Indian Himalayan region. As we all know, the Himalayas are modulating the entire climate and weather of the Indian subcontinent, and Himalayan rivers also giving us the huge water resources for sustaining millions of population in this plain and the mountain region. So Himalaya play an important role in our lives, and it is very much appropriate that we dedicate a day for the majestic Himalayas and dwell upon the contemporary challenges which we are facing to manage these water resources and ecosystem services in the Himalayan region. We all know that the climate change is one of the most serious issues faced by the Himalayas in recent times. And in this aspect, we already heard about snow, glacial, and hydrology impact and its discussion by my previous speakers. So I will be talking about relatively understudied topics of cloudburst and permafrost in the Himalayan region. Even though these topics are understudied, I feel that these are very critical questions and topic which we need to understand better to have a robust adaptive strategy against climate change and to ensure the water security and water-related hazard security in the Himalayan region. As we all know that during the last decade, Himalaya experienced a number of extreme flood events. Starting from late cloudburst event in 2010 and moving to 2013 Uttarakhand flood and some other serious cloudburst events at Asiganga and Ukhimat. These cloudburst events are all well recorded and studied. But we feel that there are a number of other cloudburst events which is occurring in this region, and lack of a cloudburst inventory in this region is actually creating roadblocks to develop a robust adaptive strategy for the region. And I'll be also talking about the permafrost in the cold-arid regions of Upper Indus Basin. This permafrost is found to be very pertinent hydrological component, which affect the water resources, disaster from landslide because of permafrost thawing, and structural instability like border roads and bridges due to permafrost thaw in the high mountain passes and regions, which is very important for the security of the nation. So these two aspects is very much pertinent to the security of the Himalayas. So while looking at the cloudburst issues in the Himalaya, what we felt that there is, as I mentioned before, there's lack of the cloudburst inventory in this region. So that actually holds us back to have an understanding of why it is happening, where we need to actually put in place the mechanisms to prevent the loss of life and the natural resources. So under this National Mission on Sustaining Himalaya Ecosystem project, which we are running for the last 4 years, we started bringing in the information of cloudburst from occurrence in the region from various sources like newspaper reports, the digital media, and the government sources, and created a cloudburst inventory for the region since 2010 to 2019. For the last 20 years, you see here this red dots actually representing the cloudburst events which we have inventoried. You can see that there are total 57 cloudburst events which we could locate. And so these are distributed in certain areas of the Upper Ganga Basin. The other issue which we faced is about the distribution of population in the Upper Ganga Basin in the mountain regions in different elevation bands. Because you all know that the mountain weather and climate is topography controlled, and each elevation have its own climate change response. So it is important to know that which elevation band and what kind of climate change is occurring. As we have seen in the last presentation, in the lower elevations of the basin, in December, while the snow cover is decreasing, the high elevations of the basin, the snow cover is increasing. So you can have different kinds of responses at different elevations. So we have geotagged almost 6,000 villages in this Upper Ganga Basin and found the elevational details. And you can see the tables here, which I've shown, is that 75% of the population lives in the elevation band of 1,000 to 2,000 meter elevation. And this is the same band where the majority of cloudburst events occurs. So around 38 number of them we have recorded, found in this particular elevation. So this particular elevation band emerged to be the very critical area for any kind of adaptive strategies which we plan for. So once we made this inventory of population as well as cloudburst, now we look into the kind of cloudburst distribution and precipitation. We have an understanding that the cloudburst usually occurs during monsoon and it occurs during the high precipitation event. But when we looked into the precipitation distribution, you all know that there are two-step topography proposed by Buchhagen way back in 2010. So these lesser Himalaya and higher Himalayan ridges have higher precipitation as compared to the valley regions in between. But when you look at the cloudburst distribution, what we are seeing is the majority of the cloudbursts are not occurring in the high rainfall zone, but on the low rainfall zone. So it is a very critical information which we derived. So this is one particular thing which we need to look into for further adaptive strategies. Collaborating with that, when we looked into the land surface temperature map and the cloudburst distribution, you can see that these cloudbursts, most of them occurs in a very high land surface temperature regions. So this land surface temperature is also playing an important role in a way to in the process supporting the cloudburst occurrence in this region. So when we looked into here we can see there are three bands which we are drawn, band 1, band 2, and band 3, based on the cloudburst the distribution. So when we looked into the topographic details, here we can see that most of these cloudbursts, and this is the orange dots which you are seeing is the villages. So most of this cloudburst occurs on the deep valley areas, where it is deep valley and the slope, which is supporting. And that is where this cloudburst intensity and more frequently occurs. In these three bands, we are seeing the same thing, and the higher elevation areas actually have a much lesser number of cloudbursts. So the high LST, and you can also see that the less of rainfall in this area. So there's a combination of high land surface temperature and low precipitation actually facilitating the occurrence of high number of cloudbursts in this area. And for actually to have an adaptive strategy, we need to know in the block level, we looked into the vulnerability of the region. So we identified Vilangana and Joshimath having 7 number of cloudbursts during the last 10 years, having a high recurrence of cloudburst, and we marked them as severely vulnerable region. And we have another 6 blocks in the upper Ganga basin have high vulnerability of around 5 cloudbursts each in a recurring fashion occurred during the last 10 years. And moderately vulnerable, you can see the Kirtner and Pauri regions. So now we have an understanding that where we need to have adaptive strategies like settlement pattern, how to change because most of the devastation occurs because there is occupation, the settlement on the mountain streams, near the mountain streams, and we need to take actions on this according to this prioritization which we made. So now we have an action, we can have a targeted action on these areas. Now, it is about, when you look at the cloudburst, it is not that the monsoon areas are only affecting. When you look back in the Ladakh region, the cold arid region where monsoon doesn't penetrate so easily, there also, we have seen number of cloudbursts occurring. The inventory which we made since 2005 to 2019, have 14 number of them we have actually counted while visiting during our field visit. Now you can see that since 2014, 2010 onwards, there are a number of events which is actually occurring. And last one which we have recorded in June, July 2019 in Roorkee village. So the cold arid systems of the Himalaya is also highly vulnerable for cloudburst. Here is an example of when we talk about cloudburst, it's the most important issue is the spatial extent of the cloudburst. So generally, most of the small events which occur in remote mountain areas are very small, and it is hardly visible on satellite imageries or any other mechanism or in the land-based monitoring. This events doesn't appear or recorded. And that is the challenge while making cloudburst inventories in this region. So here is an example where we have in 2018, we encountered a flash flood at Nubra Valley. Here, fortunately, we looked into the Sentinel image when satellite imageries. We found this image where it exactly captured at the time of cloudburst occurrence, where you can have this CB cloud here and the flood water actually flowing down the stream. So this is on Sentinel 2B image. Is on the 12th of June, which we acquired, showing this. So this area is having around 2.97 square kilometers of cloud top area. So this is the kind of, and the village down below doesn't experience any rainfall at all. So this is the kind of challenges which we encounter when we are studying the cloudburst. And most of the time, these events were missed from the researchers' preview. So under this cloudburst, there's 100 meters of road to Siachen Glacier is washed off. And this is the kind of challenges border roads encounter during this kind of events. When you look at the Nubra Valley, there is a 2015, there was an event, 18 and 2019. So high recurrence of events in this region during the last 5 years is being noted. And when we look into the reasons behind that, we already shown that in Ladakh region, the lapse rate is very high in that region, and around more than 9.8 degree per kilometer because of the aridity sustaining in this region. So that kind of lapse rate is an evidence to the high atmospheric instability, which is actually supporting the cloudburst processes. It is earlier found out that there is a land locking system which actually helps the cloudburst to lock into a place and the cloudburst occurs in that area. And that is being shown by Professor Dimri in the Okimat cloudburst. And that kind of instability, regional instability, that kind of locking is only possible when we have high lapse rate and high instability locally. So these 14 events are known, but we don't know how many unknown events are happening in the remote mountain regions. So when looked into this importance of lapse rate under NMHS project by MOEF, we have established a number of temperature stations in a regional lapse rates and this local valley ridge lapse rate. The results which we are getting is having, there are many areas which is having very high lapse rate, including Cordero region and Kashmir towards Sojila. And here you can see, even if you have a monsoon lowering of lapse rate during in the monsoon region, the local valley ridge lapse rate is always high, even in the monsoon region. And as we have seen earlier, that the high LST areas and low precipitation areas with that kind of lapse rate can facilitate the cloudburst occurrence. And so this local valley ridge lapse rate in this region is very high. This is not a single standalone station effect, but this is also true for regionally, that we have did this climatological topoclimate regime mapping, where we shown that this lapse rate in some areas can be very high, as up to 14 to 16 degree per kilometer in July and August and May and June. And so this kind of regional classification and understanding is important, not only for cloudburst studies, but also for hydrological analysis, because the hydrological models are not incorporating these regional dissimilarities of the climate system because of the topography controls into the models. So now we are trying to incorporate this kind of things, this kind of classifications into hydrological models to improve the result of the climate, the hydrological model also. The second aspect which I wanted to touch upon is the permafrost studies. Here the permafrost is having a seasonal freezing and thawing active layer, and the frozen ground and unfrozen ground on a static down. So what is most important for us is the thickening of this active layer due to climate change, because this is the area which is undergoing seasonal freezing and thawing and producing instability, and ground ice melt happens in this region, and probably it is feeding into the as a water source in this cold arid region, especially when the rainfall is in these regions is much less. So we have this study which is done in the catchment of Gangla's catchment, full-fledged experimental study, where we have seen that these areas having a huge permafrost area. This ground thermal regime at 4,900 and 5,600, we can see that at 5,600, the ground thermal regime goes up to -10 degree as compared to the -2, -3 in the 4,900. So the active layer thickness also varies from 2.5 around meters to a few centimeters in the higher reaches. So this is a huge active layer which is present in this area, and having better understanding of this permafrost regime is very important for the assessment of, as I said, the water stability and related issues. When we map the permafrost areas, we found that around more than 95% of 97% of the area is under permafrost above 4,700. So 4,900 meter, all the areas in this area could be have potential to have permafrost in this area. So under the new project, which we are expanding the studies to the entire layer district under NMHS, sponsored by Ministry of Environment and Forest. So we'll be participating with JNU, Jidipal Institute and Kashmir University, and having a wider understanding of the permafrost system of this region. So in a conclusion, I may say that the future outlook is the cloudburst is one of the high risk natural disaster affecting the people, especially in the upper Ganga basin of 1,000 to 2,000 meter elevation. And this is the areas and identified blocks are the priority areas which we need to do some adaptive measures. And present work under NMC shows how cloudburst inventory can really help to identify vulnerable blocks. And that is one of the way we identified today have to change, and it should be more monitoring like Doppler radars and other systems should be in place to catch each and every cloudburst. Then only we can say whether it is being influenced by warming climate or not. And so we need of systematic inventory of cloudburst across the Himalayan region. And second, the permafrost is a key missing link in the cryospheric process of the Himalaya, and especially in the UAB region. And these studies have to be taken up in a more energetic way, and more institutions need to involve in these studies to get a better understanding of the hydrology of Upper Indus Basin, which is very crucial for us. It's a transboundary river, and there is a lot of stake in the Indus Basin, Upper Indus Basin, especially in the current context, and we need to understand the full dimension of the permafrost and glacier and water resources in this region, especially focusing on this permafrost research also. Thank you very much for patient hearing. So moving on to the next presentation, I invite Soban Singh Rawat from NIH Western Himalayan Regional Center, Jammu. He will be speaking on spring conservation in the Western Himalaya. Soban, please switch on your mic. Yes, you can start. Welcome.
मेरा सा लैपटॉप बंद हो गया तो मैं बिस्ट के कंप्यूटर से कर रहा हूँ. I'm giving my presentation from BIST. Yes, BIST.
So you have no presentation?
Yeah. No, I have presentation. I just shift myself to BIST computer.
That's okay.
So, can you see my screen?
Yes. Go to presentation mode. Full screen mode.
Yeah.
Yes. That's right.
Good afternoon. और सभी को नमस्कार. Myself, Shobhan Singh Raut, working as a scientist at Western Himalaya Diwas Center, Jammu. And today I am presenting, I am sharing some research work on spring conservation for water security in the Western Himalaya. Actually, spring is a little bit as comparatively new topics in the hydrological studies. So I will give some basic information about the springs, and then I will talk about the work we have carried out in Western Himalaya. First, as we know that the entire world is suffering from this pandemic, but being as a hydrologist or we can say typical Himalayan people, mountain man, I have some positive news that if you see the CWC data, that this year we have more water availability as compared to the last year or last average 10 years. Even during lean season or dry season, we have more than 50 to 70% water as compared to last year. And secondly, due to this pandemic, lot of lot of youths which was migrated from the Himalayan area, they are reverse migrated to these areas. So this is good news because क्योंकि हमारे पहाड़ में एक कहावत है कि पहाड़ का पानी और पहाड़ की जवानी पहाड़ के किसी काम नहीं आती है. लेकिन but this time our jawani has returned to the Himalayan area. So let us see how our government can link their livelihood with the natural resources of Himalayas. So with this, I just start my presentation. And if you recall, in the last Catch the Rain campaign, which is normally scheduled in every Saturday, in that last Catch the Rain talk, all district magistrates are women from the different part of the country. And at that time, our Honorable Secretary said that women are the most affected most affected of water scarcity. And this is really very true if you talk about the Himalayan areas, because in the Himalayan areas, water collection for daily need is a full-time job, and that job is done by the Himalayan women. So on this Himalayan Day, I would like to salute these Himalayan women on this Himalayan women, because they compromise their dreams, how they will fulfill their dreams if they are giving sufficient time to just collect the handload of water. So this is not very good. So this is basically a summary of my presentation, that I will discuss some basic things about the spring because it is relatively new things, and some problem and consequences of drying of the spring, because in the last 2 or 3 decades, these springs are drying at a very alarming rate. And I will discuss a methodology which we have developed in different projects in Western Himalayas that we call 6-step methodology. And we have identified this approach. This is cubic meter approach, meter approach developed for spring sanctuary development. And then we'll discuss some our studies, and then we will, if time will permit, I will give some demonstration of our information system of Himalayan springs for vulnerability assessment and evaluation, issue web portals, and then calculating marks. So this is Great Himalaya. Yeah, my earlier speaker have covered these things, so I will not repeat this. But I will share this picture. This is very interesting picture, that Himalaya is very, very important because it separates not only geospatially, even culturally, 2 most populated countries of the world, that is India and China. And you will see that this entire Himalayan region is enveloped by the 2 syntaxial band. At western side, this is Indus syntaxial band, which is near Ganga Parvat, and in the eastern side, this is Brahmaputra syntax band, that is near Lemcha Barua. So so we can divide this Himalayan 3 parts, that is Western Himalayas, Central Himalayas, and Eastern Himalayas. And water, if we talk the water resources, my other speaker have already talked, but I will give some that Central Water Commission in 2017 data show that between 1984-85 and 2014 and 15, water in the Indus dropped by 27 billion cubic meter, almost equal to the average water available in the Kaveri during this time. And same thing in Brahmaputra, it dropped by 95 billion cubic meter, and in the Ganga by 15 billion cubic meter. So these data are very alarming. And same, the catchment area is also decreasing because there is a lot of degradation in this catchment. So the in 2004, between 2004 to 2014, the catchment area of Indus reduced by 1%, and Ganga by 2.7%, and Brahmaputra by 0.6%. So if you see the demographic pattern in the Himalayan area, the most majority of the population concentrated in the middle Himalaya, or sometimes we can lesser Himalaya, that is between 1,000 to 3,000 meters. Most, if you see the most of the cities, Himalayan cities are located between these altitudes, and in these altitudes, rivers flowing in the deep valley and glaciers are in far-flung areas. So springs are the only easily available source of drinking water as well as other needs. So if you look in the Himalayan area, every village or hamlet is located near the springs. So I will call this spring civilizations. If there is a spring, there will be definitely a village. And if mountain water springs and these springs are basically the natural door in the groundwaters. And this is not only natural door. This is an entire system where outage is one position, and aquifer is another position, and catchment is another position. So all these three are connected, but located at different geographical positions. And these springs are locally called as Chasma, Nag, Chumik, Manya, Nadu, Bauri, Cheradu, Dauda, Naula, in different part of the Indian Himalayan regions. If we talk the springs, there are 4 regions in India where springs generally form. Indian Himalayan region, Central and Western Ghat and Eastern Ghat. I will not go in detail. If we talk about there are 5 kinds of springs found in India. Major springs are depression type. Depression type of springs are like when water table intersect with the groundwater, with the earth's surface. Due to the abrupt change in the slope, at that point, spring was in the form of depression springs. And second is contact springs. These springs are emerges between the contact of 2 layers, overlying layers, pervious layer, and underlying layers, impervious layers. So between these contact type of springs emerge from the contact of impervious and pervious layer. Our fractures and fault springs emerge from the fractures or fault in rocks. So there is a little difference in contact springs and fracture springs. If there is a number of springs on a contour in horizontal direction, this means this is the contact spring. If there are springs located in vertical direction, then it will be definitely fracture springs. And 4 types of flash springs. When acidic rainwaters infiltrate into the limestone rocks, then it dissolve the calcium and make some sinkholes or cavities through which water moves under the ground, and after some time it emerges on the earth's surface in the forms of spring. That spring is called karst springs. Our Panganga spring, Mata Vaishno Devi spring is the best example of karst springs. And if you talk about hot springs are basically the springs which have been higher water temperature as compared to the ambient, and these springs emerge from the different geothermal provinces. There are 6 kinds of geothermal provinces in the country, and this area, Ladakh and Jammu Kashmir, this comes where heat flow is more than 180 milliwatt per square kilometer. So the most hot springs belongs to this particular areas, and sometimes, especially in some Andaman and Nicobar area, when water passes through the volcanic zones, then water get temperature, and in that situation, hot water springs emerge. And it has been seen that people assume that the genesis of hot springs is due to the sulfur, because most of the hot springs having curative property, but that is not actually right, because at the normal condition, cold water does not react with sulfur. But once this water gets temperature, then it reacts with the sulfur dioxide, and it gets the curative properties. And these are some hot springs in different part of the India. There are almost more than 400 hot springs in the country. And if we talk the dependency, there is a high dependency on the springs, because about 50 million people of Indian Himalayan region depend upon these springs, and more than 200 million people are depending upon these springs. Not only in the Indian Himalayan region, even the people living in the plain area, they are also depend upon the entirety. They are also depend upon the springs, because the base flow of most of the river, which is originated from the Himalayan area or mountain area, the base flow is maintained by these springs. So indirectly, the people living in the plain area is also dependent on these springs. And but in last 2 or 3 decades, these springs are drying at a very fast rate across the Indian Himalayan regions, either in Himachal Pradesh or in JNK or in the northeast area. There are a lot of examples of drying of these springs. And due to the drying of these springs, these are the consequences. You can see the long queue of ladies and children in the Indian Himalayan regions. Even people are putting lock on their springs so that it cannot be tapped. Or there are some places in the Uttarakhand and Himachal which is called ghost villages, because it is totally migrated. And I am not saying that the whole region of migration is only water, but water is also a very important region of this migration, which is this migration. So there are a lot of ghost villages in the Himalayan areas. And but in earlier, if we talk olden days, people have some respect about of these springs. If you see that every springs have a temple or a banana tree or a people tree. So this is the way that people are respecting these springs, so that they can preserve or they can protect these springs. You can see that this is the Nola, which is normally found in Mount region. The roof of the Nola is 4-sided. That is actually temple roof. So people have such kind of local tradition to preserve these springs. If we talk about the region for drying of springs, so anthropogenic is no doubt anthropogenic is the major reason of drying of these springs. But climate change exacerbated the rate of drying of these springs. You will see that in last 15 years, the Himalayan population grew by 250%, with an annual growth rate of 3.3%, which is 3-fold to the world average growth. So, how we can accommodate this population in a fragile ecosystem? This is very great challenge, and these are the regions where, due to which these springs are drying at a very fast rate. And if you see this, yes sir.
थोड़ा फास्ट करना है, अपना जो वर्क है NIH का वो बता देना.
Okay sir. Okay. So let us see this picture. I am just showing this picture because this is very important, because there is a need of paradigm shift to be needed, source to resource. We are our water policy talking about the source creation. But you will see there are two glades. One is at top of the mountain, at bottom of the mountain. Bottom of the mountain place having one springs, and top of the mountain place don't have any springs. So they have borewell. So they will not do any water conservation activities because they don't have any benefit of this particular springs. But if you see that this borewell withdrawing water from the aquifer of these springs, so we have to change this mindset that we can think about the resources. And another problem is there is a mismatch between the spring demand and supply, because when the spring discharge is high, especially after monsoon, at that time the demand is low. But when in May and June, which is tourist season in Himalayan areas, at that time the spring discharge is very low and demand is very high. So there is a mismatch which is also responsible that these springs could not become the part of our policy. So these are also the regions due to which these springs could not become the part of our policy. But there are some efforts have been done in the recent past, and Sikkim Springs is very very good model in which different community-based programs. It is a community-based program with the help of different international organizations and different government departments and different NGO, in which 50 springs, 5 lakes, and 7 hilltop forests have been revived. This is the best example of spring site management across the country, and we have also do some assessment of these springs, and we found that even in 1 year of treatment of spring site treatment, we have taken 4 spring data, and there is a significant increase in aquifer recharge, that is 89%, 111%, 133%. So this is very successful program. But this program could not be replicated in other parts. So there is some conditions in Sikkim state. Sikkim state is a very small state. It is only 7,000 square kilometer area. Even my district, Uttarakhand, it is greater than entire Sikkim state. So there are a lot of even district which is greater than Sikkim states. And the normal annual rainfall of Northeast India is about 2.54 times of Western Himalayas. And the most longest monsoon season is Northeast India is it is more than Western Himalayan regions. And the most extreme dry spell in Western Himalayas is 156 days, and in Sikkim it is just 80 days. So we cannot copy Sikkim model in another part of Indian Himalayas. So we have started some pilot project in Western Himalayas so that we can develop a protocols for the spring management. And this is the 6-step methodology that we have developed in these springs. This methodology basically depends upon a cubic meter approach, that is motivate. We have to motivate the people that they can understand the significance or importance of springs. Then we will mentor some spring site management program so that people can understand that what is actually spring site management program. And after successful mentoring of this program, then people themselves start some spring site management program, and at that time we will monitor their discharge, that their spring site development program is going in right direction or not. And this entire cubic meter approach is depend upon 6-step methodology, that is spring mapping, identification, vulnerable springs, monitoring of database, spring site mapping, adaptive solution for implementation, and para-hydrology. And these are the 3 catchments where we have adopted this methodology. In one Banganga catchment near Vaishno Devi, another is Ravi River catchment in Himachal Pradesh, and another catchment is Kavi River in J&K. I will skip this. And these 24 parameters we have collected during the survey, or that is 20 is normal parameter, 40 is water quality parameters. And this is the format of we have developed. We have also developed a mobile app through which we can collect the data. And this is the format, different information regarding. And these are the different activities, field activities. And this is the web portal. This is the concept of web portal in which we have integrated GIS and internet to create, store, assess, and represent different multivariate data systems through GeoServers. So that because these are the open source tools, so this is very low cost technology. And this is our web portals. I will just demonstrate one. This is our web portal, and this is developed under purpose-driven study, sponsored by National Hydrological Project. And this is Ravi River catchment. These are the springs which is already geotagged. And if somebody is interested to get detail of any springs, so get spring informations from here. You just double click, and you will get the photograph of that springs. This is spring ID, date of survey, discharge, and if you want detailed information, view more details. And this is the general informations, and these are some information: elevation, latitude, longitude, demographic, how many people are dependent on these springs, and this is water quality information. So all information are available on just a click of mouse. And this is a training of para-hydrologists, so that after what happened, the project after completion of this project, that local people can manage their spring set. And these three or four technology we have used to identify the recharge area of the spring, that is hydrological, environmental, isotopic, and water chemistry and geological. And these are very important because hydrological analysis will very helpful to define to understand the storability and transmittivity of aquifer, that which will decide that this spring will be suitable for recharge or not. And same we can identify the depletion time of spring, that after once the spring will recharge, after how many long time, how many months it can last. And this is that how we can make a spring a dependable source, because there is a mismatch between demand and supply. So if you construct a minimum storage tank at there, so we can increase the potential of any spring like this Bhumika Devi spring from 550 people to 970 people, just making a storage tank. And this is the isotopic techniques that we have used in Ravi River project and Banganga project. And in this we have installed rain gauge at different altitudes, so that we can catch the isotopic effect of rain. And these are the how we can identify the source with the help of isotopic methods, and how we can identify the altitude of recharge area with the help of isotopic techniques. And this is a chemical analysis, because it is very important, because it gives information about the host rock which is presented in the recharge area. And this is some geological analysis in the areas, in the Banganga and Ravi River catchment to identify the recharge area of these springs. And these are some conclusions. Spring data center has to be established under an institute or department of Government of India, which will manage the spring portal. The methodology developed by NIH or other institute at catchment scale can be extended in different climatic and geological zones of the country for developing protocols, which can be further scaled up to the IHR or pan-India level. Identification of recharge area for rejuvenation of spring is not a low-hanging fruit. Needs proper integration of outcomes from hydrological, chemical, isotopic, and local geological analysis with traditional knowledge. Good coordination is required between research institute and state implementing agencies for effective spring site management program. Spring can be incorporated in the environmental management plan. After conducting more research to understand the effect of land use change, mining, tunneling, road cutting, etc. on spring groundwater hydrology. Need to encourage private sector to invest their CSR, corporate social responsibility funds, even some campus responsibility from there, as our secretary sir mentioned in last meeting in spring site management. Thank you very much.
Thank you, Soban, for giving a detailed information about what we are doing about the springs in this region. And now I invite Dr. Prabhash Misra for giving a talk on vulnerability assessment in the Upper Ganga Basin.
Thank you, Dr. Rinoj. At the outset, I welcome all and a big congratulations on the occasion of Himalaya Day. So I will be presenting on the vulnerability assessment in the Upper Ganga basins. During the last 1.5 hours, you can see a lot of previous speakers. Yeah, the other speakers, they have already spoken a lot on the Himalaya and its importance, but we all come in the same page that the Himalaya and particularly the Upper Ganga basin highly significant in contributing towards the livelihood of people living in the mountain areas. But equally significant is the difficulties and the issues faced by the people in those areas. In the next 10 to 15 minutes, I will be focusing on the survey-based analysis of mapping of Upper Ganga Basin villages. We have conducted intensive village survey in the last 2 to 3 years. And secondly, I will be discussing on the how to identify the vulnerable blocks in the Upper Ganga Basin using one IPCC approach, that is LVI, Livelihood Vulnerability Index. So these two aspects I will be covering in the next 10 to 15 minutes. Already you know about the Upper Ganga basins. As Dr. Goel has already told you, it has a important river system, and it has a geographical area of something around 22,000 square kilometer. But this UGB is coming under 8 administrative districts, as you can see. But 5 prominent districts are coming over here, excluding the Kinnor from Himachal Pradesh, Pithoragarh and Bageshwar. Very little area is falling in this UGB, and it has 39 administrative blocks. So our analysis is based on the block level. And as I have already told you, this terrain is very difficult to work with high slopes. You can see the elevations of this particular area starting from 324 meter to something around 8,000 meter in elevation. So it is very challenging to work in this particular Upper Ganga Basin. But in the last 2-3 years, we have conducted a lot of village survey and household survey as well. You can see we have already have our footprint in 231 villages and 526 households from different districts, starting from Tehri Garhwal, Rudraprayag, Uttarkasi, Chamoli, and Pauri Garhwal. But let me tell you that before going to the conducting the village level survey, we identify these villages based on different attributes such as elevation, rainfall, and population density. So initially, we identify all the villages where we need to target based on these attributes. Then we form one team and deploy one team, and then we conducted our survey. This is the spatial distribution of villages we have already surveyed during last 2 to 3 years. So our survey is based on a particular questionnaire, as you can see. We have, these are the broad queries attempted during the survey. As you can see, these are 6 major attributes, starting from taking the basic village level informations, like what is the condition of the road, how many households are existing in a particular village, what is the population distributions, literacy, landholding. Then we look at the water availability and the utilization, what are the different sources of water with their locations. And another aspect is how far the people they are traveling to and time they are spending how to fetching this water. Also, we look at the utilization, how these water sources are utilized in that particular village. That also we looked at. Again, in the third component, as you can see, we look at the water adequacy and quality. We go with the source-wise water adequacy. And if there is any inadequacy, we look at when exactly the inadequacy was faced by the people. That also we looked at. We also look at the water quality. What are the different water-related issues? What are the water-prone diseases in the last 10 to 15 years? Also, we look at the provision of, is there any provision of rainwater harvesting in the area? Next, we explored on this climate change aspect. We heard a lot about this climate change. So we tried to discuss through the focus group discussion that what is the likely impact of climate change in the last 10 to 20 years to the people. And we look at the change in temperature during the summer and winter. So these are the key attributes we covered during our survey based on the questionnaire. Then we look at the disaster and adaptation mitigation strategy available in the villages. As you can see, is there any provision of disaster-prone system? Like, is there any provision of before the disaster occurred, during the disaster, or post-disaster? So these are the indicators or themes, you can say, which we put in the questionnaire, and we moved on to the field for survey. And lastly, we covered the socio-economic and cultural aspect. Here we look at the livelihood practices. Is there any tourist destination nearby to the villages? Again, we look at the migration also in our questionnaire. So based on the 231 villages survey, these are the findings. Few findings I will be showing which are very vulnerable in terms of vulnerability. Here you can see, look at the dependency of the different villages on the drinking water. As you can see, Spring and Gadhera. Gadhera is nothing but the small rivulets found in the upper reaches of the Himalaya. As you can see, almost 70% of the villages are depending on the Spring and Gadhera to meet their different water needs. And spring water is the primary source of water in majority of the villages. but due to poor maintenance, the springs tend to cave in during the landslides and it becomes dry up. Next, we talked about the water adequacy. As you can see, 84% of the surveyed villages reported inadequate and inconsistent supply of water. And the inadequacy is mostly found during the peak summer in the month of May and June, and during peak winter also during December and January. And this scarcity has also an elevation impact. As you can see, in the low elevation zones during May and June, the water sources are drying up. So this is the reason why people are facing a lot of difficulty in meeting their water requirement. But in the high elevation, it is due to the freezing of water in the pipeline, which puts a lot of problem to the people. We also look at the reasons for inadequacy. As you can see, the rainfall received in this area is very erratic and very less as per the trend, and the infrastructure developed is also inadequate, and there is also mismanagement in the water distribution. So these are the few reasons which can be attributed to the inadequacy. Next, as you can see, there are different major environmental issues starting from deforestation, soil erosion, dried up stream, land use changes, climate change. So all the villages confirmed a change in the land use and climate, which in turn impacts their livelihood. Drying up of stream and high erosion are also other issues which affects the agricultural activity in the region. And most of the villages, they have reported increase in temperature during summer and winter season and decrease in trend in the rainfall and snowfall and an unseasonable pattern in the UGB. Coming to the natural disaster they are witnessing, as you can see, flood, drought, landslide, earthquake, forest fire, and glove and cloudburst. These are the major disasters mostly related to the water they are facing. And there is no disaster warning system reported in any villages from the 231 we have surveyed. And there is no provision or policy for rehabilitations post-disaster in most of the villages also. We also look at the landslide zone. As per the NDMA, Uttarakhand state is classified as a high hazard landslide zone. In our survey also, as you can see, 79% of the surveyed villages reported to be affected by landslide, mainly during the rainy season. So it is in confirmation with the NDMA also. Then coming to the livelihood practices followed in the UGB, as you can see, agriculture is the prime occupation in the Upper Ganga Basin. Almost 90% of the villagers, they depend on the agriculture and animal husbandry, and few households, they also carrying out this small business, petty business kind of things. And many male persons from different villages, they have joined armed forces also. And most farmers, they have small and marginal land holdings. Nearly 100% of the agricultural activities rain-fed in those regions. And these are the prominent major agricultural produce. As you can see, vegetables, wheat, and in the upper reaches of the UGB, you can see apple production in higher elevation. Coming to the migration, as already Dr. Goyal has shown you, migration is also very vivid in the Upper Ganga basins. 79% of the respondents, they have acknowledged that issue of migration is real, and some permanently while others are temporarily, due to the unavailability of basic amenities like employment, education, and medical facilities. Pauri Garhwal district, as you can see, more than 90% of the respondents, they have reported migrations from their villages. This is also another aspect which we are looking at. We have segregated the different villages within 1 kilometer distance from the major stream of order 3, 4, 5. As you can see, there are 705 villages within the vicinity of 1 kilometer in the Upper Ganga basin from different major stream. But why I am showing this is that look at the dependency of different people in the lower order stream. So most of the people, they are meeting their water needs from the stream order like 1 and 2. So this is also one of the, key areas which you can look at. Up to this point, I have already told you what are the key challenges, what are the vulnerable components we are looking at the Upper Ganga Basin in different villages. But from this slide onwards, I will be telling you how these blocks are identified from vulnerable point of view using one index suggested by IPCC, that is known as Livelihood Vulnerability Index. As you can see, it has three contributing factors. One is your exposure, another is your sensitivity, and third one is your adaptive capacity. If a particular village or particular zone is highly exposed to different disaster, if it is highly sensitive, for example, if there is a lot, the population density is high in a particular zone with less adaptive capacity, that particular zone will be highly vulnerable. And the vice versa is when there is less exposure, less sensitivity, and high adaptive capacity, that particular region will be less vulnerable. So based on this LVI index has been ranged from -1 to +1, indicating low to high vulnerability. And we have assessed our vulnerability at block level that I will be showing in the next few slides. So as I have already told you, three contributing factors. One is your exposure, sensitivity, and adaptive capacity. I have considered 7 major indicators. These are climate change and natural disaster, demography, water, health, livelihood, social network, and food. Every major indicators have different sub-indicators. There are total 25 sub-indicators. Like in the climate change and the natural disaster, you can see there are 4 sub-indicators. Similarly, in the demography, there are 6 sub-indicators. So all these sub-indicators, it has been, we have carried out the household level survey, and all the information have been captured. So once we have the information, so we try to assess the sub-indicators wise profile value of every sub-indicators. As you can see, here you can see demography is one of the sub-indicators with 1, 2, 3, 4, 5, 6 sub-indicators. Here you can see there are 3 values. One is your given value, another is your minimum value, another is your maximum value. Suppose in a particular district we have 3 blocks. So from 3 blocks, the minimum value and the maximum values are chosen, and the given value is for the particular block. Since the information scale and units are different, so initially we standardize the value for every sub-indicators. As you can see over, using the formula, a given value minus the minimum value divided by the range of that particular range of the value. So once the standardized values are assessed or estimated, then we go to estimate our profile value. That is nothing but the mean of the standardized value. Here you can see the profile value for demography is 0.66. So in this way, we try to assess the every sub-indicators and indicators for the major components, as you can see, and we provide a weight. Weights are nothing but the sub-indicators for different indicators. So in this way, once we assess or once we estimate profile value for all the indicators, then we found the weightage average of every major component. As you can see, the contributing factor for sensitivity is 0.45. Once we know the sensitivity, adaptive capacity, and exposure, this contributing factor, then we use the formula LVI IPCC, that is your livelihood vulnerability index, is nothing but the exposure minus adaptive capacity multiplied with the sensitivity. Here, as you can see, minus 0.21 is for a particular block. So this is the wave diagram for all the sub-indicators. Here also you can see, this is for the Rudraprayag district. As you can see, the demographic component is something around 0.67 around for the August Muni. So it is high in case of August Muni block, but in the same way, the social network, as you can see, it is high for the Ukhimat block. So in this way, all the contributing factors and the profile value and your contributing factors, these are assessed, and this block vulnerability is finally assessed. Here you can see the wave diagram for the exposure, adaptive capacity, and sensitivity for the 3 different blocks. So these are the LVI index. So based on this LVI index, we try to rank the vulnerability of different blocks. As you can see, Jokholi block is highly vulnerable in comparison to Ukhimat and August Muni block. In the same fashion, what we try to do for 3 districts, covering different blocks. We tried to assess the exposure for Uttarkasi, Rudraprayag, and Tehri Garhwal. Then we assess the adaptive capacity for different blocks, and finally we come up with the LVI IPCC, that is your vulnerability index. So based on after finally assessing all the vulnerability index for different blocks, we prioritize or rank the blocks in this fashion. As you can see, Bhatwari and Vilangana are two blocks from Uttarkasi, and this is from Tehri Garhwal. These are the two prominent blocks which are highly vulnerable among the three districts. So in this way, the ranking is done so as to prioritize our different blocks for government interventions. So this is all about my presentation. I thank you to my study team, particularly Dr. Rinoj, Dr. M.K. Nema, Dr. Pradeep, and my staff, Swagatam, Hemant, Vishal, and Pankaj and Sanjay. And this particular study is sponsored by DST under NMC. Thank you very much.
Thank you, Prabhash. Next is, I invite Dr. V.C. Goyal for giving a talk on water security and environmental carrying capacity for Indian Himalayan region.
Yes, sure. Thank you, Renos. अभी आपने मेरे कुलीग्स को सुना जो हाइड्रोलॉजी की डिफरेंट एस्पेक्ट्स को कवर करते हुए इंडियन हिमालयन रीजन में जो कॉम्प्रिहेंसिव वर्क NIH कर रहा है उसके बारे में उन्होंने आपको बताया है। सभी एस्पेक्ट्स हिमालय के जो कवर कर रहे हैं उसमें ग्लेशियर है, स्नो है, ग्लेशियल फ्लड्स हैं और स्प्रिंग्स हैं। तो इन सब में जो काम हो रहा है उसको प्लानर की पर्सपेक्टिव में और जो हमारे यूनाइटेड नेशंस का सिस्टम है या नीति आयोग का सिस्टम है वो जो टर्मिनोलॉजी समझते हैं उसमें कैसे फिट होगा उसके बारे में थोड़ा सा मैं आपके साथ शेयर करूंगा। दिस इज ऑन वाटर सिक्योरिटी एंड एनवायरमेंटल कैरिंग कैपेसिटी। प्रॉब्लम्स हम सभी जानते हैं, वाटर रिलेटेड प्रॉब्लम्स इन जनरल इंडिया में और वही काफी कुछ हिमालय में भी हैं। वाटर सोर्सेज का पोल्यूशन है, वाटर अवेलेबिलिटी की कमी है, वेस्टेज और इनएफिशिएंट यूसेज ऑफ वाटर है, ग्राउंड वाटर डिप्लीट हो रहा है, अनसस्टेनेबल है और जितनी हमारी वाटर बॉडीज हैं वो डिजनरेट हो रही हैं और यूज में नहीं है। वाटर स्कैर्सिटी हम सभी जानते हैं कि एक ग्लोबल इशू है और इंडिया में काफी सीरियस कंडीशन है और इस समय हम लोग कहीं 1400 के आसपास मीटर क्यूब में होंगे और 2050 तक काफी सीरियस सिचुएशन होने वाली है। अभी जो जैसे मैंने कहा कि यूनाइटेड नेशंस और नीति आयोग या जो हमारे प्लानर्स हैं वो जो उनके लिए इम्पोर्टेंट है वो है जैसे सस्टेनेबल डेवलपमेंट गोल्स। एजेंडा 2030 में सस्टेनेबल डेवलपमेंट गोल्स डिफाइन किए गए हैं। 17 SDGs हैं जिनको बनाया गया। उसमें से जो वाटर के लिए सबसे ज्यादा इम्पोर्टेंट माना जाता है वो है SDG 6, जो क्लीन वाटर एंड सैनिटेशन की बात करता है। वाटर और भी कुछ SDGs में आता है, लेकिन मेन कवरेज उसका SDG 6 में है। और SDG 6 में अगर आप देखें तो उसके 8 टारगेट्स हैं, जिसमें बहुत सारे इंडिकेटर्स उन्होंने डिफाइन किए हैं उसको मॉनिटर करने के लिए। तो फर्स्ट टारगेट है 6.1, वो ड्रिंकिंग वाटर से रिलेटेड है। 6.2 सैनिटेशन और हाइजीन से रिलेटेड है। 6.3 वाटर क्वालिटी एंड वेस्ट वाटर की बात करता है। 6.4 वाटर यूज एंड स्कैर्सिटी की बात करते हैं। 6.5 में वाटर रिसोर्स मैनेजमेंट है, जिसमें IWRM भी उसका आता है। देन 6.6 इज अबाउट इकोसिस्टम्स। 6.6A और 6.6B ये दोनों कोऑपरेशन एंड पार्टिसिपेशन के बारे में है, जो इंटरनेशनल इश्यूज हैं और ट्रांसबाउंडरी इश्यूज हैं उसके बारे में कोऑपरेशन कैसे हो। तो इस तरह से ये 8 टारगेट्स हैं SDG 6 में, और उसी में हमको जो भी हम स्टडी करते हैं, जो NIH जो इतनी अच्छी स्टडीज कर रहे हैं, उसको उस टर्मिनोलॉजी में लाना पड़ेगा जो SDG 6 की रिपोर्टिंग में काम आ जाए या हमारी प्लानिंग में काम आ जाए। तो जब हम वाटर सिक्योरिटी की बात करते हैं तो यूनाइटेड नेशंस ने डिफाइन किया है कि व्हाट इज वाटर सिक्योरिटी इज द कैपेसिटी ऑफ ए पॉपुलेशन टू सेफगार्ड सस्टेनेबल एक्सेस टू एडिक्वेट क्वांटिटीज ऑफ एक्सेप्टेबल क्वालिटी वाटर। तो क्वांटिटी एंड एक्सेप्टेबल क्वालिटी वाटर, उसके यूज किस लिए? फॉर सस्टेनिंग लाइवलीहुड, ह्यूमन वेलबींग, सोशियो इकोनॉमिक डेवलपमेंट, and for ensuring protection against waterborne pollution and water-related disasters, and also for preserving ecosystems in a climate of peace and political stability. तो ये सब जो इसकी डेफिनेशन में, वाटर सिक्योरिटी की डेफिनेशन में है। और बेसिकली वाटर सिक्योरिटी जो बात करता है तो वो ड्रिंकिंग वाटर सिक्योरिटी, it talks about securing food supply. It also talks about water for health, for protecting ecosystems, managing risk जैसे फ्लड, ड्राउट, पोल्यूशन और वो सब जो हजार्ड से उनके रिस्क को मैनेज करना है। वाटर फॉर सिटीज, जितना अर्बनाइजेशन और डेवलपमेंट हो रहा है, इकोनॉमिक एक्टिविटीज हो रही हैं, उसके लिए वाटर सिक्योरिटी करना है। एंड वाटर फॉर इंडस्ट्री। तो बेसिकली ये डायमेंशंस हैं जो वाटर सिक्योरिटी जिसके लिए करना है। और ये इस तरह से वाटर सिक्योरिटी मैट्रिक्स भी बनाया गया है। ग्लोबल वाटर पार्टनरशिप है जो इस एरिया में काम करते हैं, तो उन्होंने इसको दो तरह से 2 एक्सिस बनाया है। ऑन वर्टिकल एक्सिस वी हैव वाटर स्ट्रेस कंडीशंस और उसकी कैपेबिलिटीज। ऑन द एक्स एक्सिस वी हैव कोपिंग कैपेसिटी, जो स्टेक होल्डर्स हैं या जो हमारे सिस्टम्स हैं उसकी कोपिंग कैपेसिटी कितनी है। तो वाटर स्ट्रेस में लो एंड हाई, ऐसे ही कोपिंग कैपेसिटी में लो एंड हाई। तो अगर हम लो वाटर स्ट्रेस में हैं और लो हमारा कोपिंग कैपेसिटी है तो नथिंग मच टू वरी, वो हम फर्स्ट क्वाड्रेंट में हैं। जो नीचे आप क्वाड्रेंट देखेंगे, सेकंड क्वाड्रेंट, वो रियली वरिंग है कि उसमें आपका वाटर स्ट्रेस हाई है लेकिन कोपिंग कैपेसिटी लो है। तो और जो यहाँ पर आप ग्रीन में जो क्वाड्रेंट देख रहे हैं वो बेस्ट कंडीशन है कि जहां आपका वाटर स्ट्रेस लो है लेकिन कोपिंग कैपेसिटी हाई है। तो हमको इस रेड वाले क्वाड्रेंट से अल्टीमेटली मूव करते हुए ग्रीन वाले क्वाड्रेंट में जाना चाहिए। और उसके लिए जो भी हमको साइंटिफिक मेथड्स हैं या जो हमारे इम्प्लीमेंटेशन के मेथड्स हैं उसको लगाना होगा। अब जब वाटर सिक्योरिटी असेसमेंट है तो ग्लोबली वाटर सिक्योरिटी असेसमेंट के लिए वाटर सिक्योरिटी इंडेक्स एक बनाया गया है। नीति आयोग इंडिया में उसके लिए नोडल एजेंसी है जो उसको मॉनिटर करता है कंट्री लेवल पर। और कंट्री लेवल का जो वाटर सिक्योरिटी इंडेक्स है उसको अराइव करने के लिए हमको स्टेट लेवल से जाना पड़ेगा और उसके नीचे डिस्ट्रिक्ट लेवल में जाना पड़ेगा। तो डिस्ट्रिक्ट लेवल का वाटर सिक्योरिटी इंडेक्स वो एग्रीगेट होगा, स्टेट वाटर सिक्योरिटी इंडेक्स, और फाइनली कंट्री का वाटर सिक्योरिटी इंडेक्स, वो फिर ग्लोबली मॉनिटर होता है। इस समय हमारा वाटर सिक्योरिटी इंडेक्स बहुत लो है क्योंकि हम इग्नोरेंट हैं कैसे इस इंडेक्स को कैलकुलेट करना है, क्या डेटा उसके लिए चाहिए, कैसे उस डेटा को ऑब्टेन करना है, वो अभी उसमें काफी हमारा इग्नोरेंस है। तो अगर आप देखें वाटर सिक्योरिटी इंडेक्स कैसे कैलकुलेट होता है, तो उसमें वाटर डिमांड और सप्लाई सिचुएशन है, क्लाइमेट चेंज का इम्पैक्ट उसमें कंसीडर होता है, जो हमारा इंफ्रास्ट्रक्चर है उसका असेट मैनेजमेंट और फंक्शनैलिटी कैसा है, इंफ्रास्ट्रक्चर प्लानिंग एंड डेवलपमेंट हमारा कितना कैपेबिलिटी है, इंस्टीट्यूशनल रेगुलेटरी फ्रेमवर्क कैसे हैं, और ह्यूमन एंड इंस्टीट्यूशनल कैपेसिटी कितना है। इन सब को कंसीडर करते हुए वाटर सिक्योरिटी इंडेक्स कैलकुलेट होता है। आई एम नॉट गोइंग इनटू डिटेल्स ऑफ कैलकुलेटिंग दिस इंडेक्स, लेकिन आप ये देखें कि उसके लिए कुछ इंडिकेटर्स डिफाइन किए जाते हैं इन टर्म्स ऑफ वाटर अवेलेबिलिटी, वाटर एक्सेसिबिलिटी, वाटर क्वालिटी एंड सेफ्टी, एंड ऑल्सो वाटर मैनेजमेंट, जिसमें गवर्नेंस का भी इशू आता है। इन सब को करते हुए हम वाटर सिक्योरिटी असेसमेंट करते हैं। और अगर हम बात करें कि सोर्स वाइज क्या हमको थ्रेट्स हैं और क्या एक्शन लेना चाहिए, तो जैसे रेन वाटर है हमारा सोर्स, तो उसमें हमारी जो थ्रेट्स हैं वो क्लाइमेट चेंज की थ्रेट है बेसिकली ब्रॉडली, और उसमें एक्शन हमें क्या चाहिए कि कलेक्ट एवरी ड्रॉप, जो इस समय हमारी मिनिस्ट्री का भी इस समय कैंपेन चल रहा है। तो कलेक्ट एवरी ड्रॉप, जो हमारे सरफेस वाटर के सोर्सेज हैं, रिवर्स, टैंक्स, पॉन्ड्स, लेक्स, इन सब में थ्रेट्स हैं हमारा इवापोट्रांसपिरेशन, जैसे क्लाइमेट चेंज भी है, इवापोट्रांसपिरेशन है, पॉल्यूशन, सिल्टेशन, अर्बनाइजेशन, ये सब इसके लिए थ्रेट्स हैं। और वहां हमको क्या एक्शन चाहिए, कंजर्वेशन चाहिए, सस्टेनेबल यूज एंड इक्विटेबल शेयरिंग, फॉर एग्जांपल थ्रू पानी पंचायत। जो ग्राउंड वाटर के सोर्सेज हैं जैसे स्प्रिंग्स या एक्विफर, उसमें थ्रेट्स हमारा है वाटर माइनिंग, क्लाइमेट चेंज, पॉल्यूशन, अर्बनाइजेशन, और उसके लिए एक्शन डिजायरेबल है सस्टेनेबल एक्विफर मैनेजमेंट। अब अगर हम वाटर सिक्योरिटी की बात कर रहे हैं तो उसमें जो डिजास्टर्स हैं, वाटर रिलेटेड डिजास्टर्स, वो बहुत ज्यादा इफेक्ट करते हैं, और उनकी जो फ्रीक्वेंसी और सीवियरिटी है डिजास्टर्स की, वो हम देख रहे हैं कि अभी बिकॉज ऑफ इम्पैक्ट ऑफ क्लाइमेट चेंज वो काफी इंक्रीज हो गई है फ्रीक्वेंसी, और सीवियरिटी भी इंक्रीज हो गई है। और इन डिजास्टर्स की वजह से जो मास डिस्प्लेसमेंट होता है पॉपुलेशन का, जैसा अभी हम देख रहे हैं कि इस सीजन में भी हमारे जो डिजास्टर्स आए हैं, नॉट ओनली इन हिमालयन रीजन, जो साइक्लोन आया है या जो हमारा क्लाउड बस्ट वगैरह हुआ है, तो उसमें भी डिस्प्लेसमेंट ऑफ पॉपुलेशन हो जाता है, और वो और दूसरी प्रॉब्लम्स को जनरेट करता है। तो जो वल्नरेबिलिटी के लिए अभी डॉक्टर प्रभाष ने आपको डिटेल्ड मेथोडोलॉजी बताई, वल्नरेबिलिटी मैपिंग जो वाटर सोर्सेज का है वो एक डिजायरेबल स्टेप है, क्योंकि हम जब भी वाटर सिक्योरिटी असेसमेंट करेंगे तो वी शुड नो विच आर द वल्नरेबल वाटर सोर्सेज। और रेसिलियंस की अगर हम बात करें कि अगर वाटर सप्लाई सोर्सेज का, सिस्टम्स का रेसिलियंस हमें डेवलप करना है इस तरह के सिचुएशंस में, जैसे अभी भी हम कोविड में भी देख रहे हैं, तो उसके लिए ये वल्नरेबिलिटी असेसमेंट बहुत इंपॉर्टेंट है। और वाटर रेसिलियंस जो हम देखते हैं कि अगर इमरजेंसी की सिचुएशंस हैं, जैसे अभी कोविड में है या डिजास्टर्स में होता है, अगर हमारे वाटर सिस्टम्स रेसिलियंट हैं तो वो कम्युनिटी को हेल्प करते हैं, कम्युनिटी उससे बेटर कोप करती है। और जो इसके लिए डिसरप्टिंग फैक्टर्स हैं जो रेसिलियंस को डिसरप्ट करते हैं, वो है हमारे जैसे एक्सट्रीम इवेंट्स, ड्राउट, फ्लड, साइक्लोन, वाटर स्कैर्सिटी सिचुएशंस एंड वाटर कंटामिनेशन। तो रेसिलियंट सिस्टम होने के लिए the system should have ability to absorb disturbances and reorganize itself into a better configuration. अभी भी जैसे बात हो रही है कि अब जितने हमारे वाटर सिस्टम्स हैं वो इस कोविड के बाद वो नए नॉर्मल में आएंगे, तो दे शुड अडॉप्ट, एब्जॉर्ब दिस डिस्टर्बेंस एंड कम अप with better configuration. और इसके लिए हमें चाहिए प्रोटेक्शन एंड कंजर्वेशन ऑफ वाटर बॉडीज। इसमें बहुत सारी स्कीम्स जैसे चल रही हैं, भारत सरकार की भी और कुछ प्राइवेट भी। चेन्नई सिटी में बहुत सारे डेड वाटर बॉडीज को रिवाइव करने का प्रोग्राम चल रहा है। महाराष्ट्र में मराठवाड़ा रीजन में मोर देन 30,000 स्मॉल डैम्स और रिजर्वायर्स को डीसील्ट कर रहे हैं। इसी उसमें NIH ने उत्तराखंड में और उत्तर प्रदेश में कुछ विलेज पॉन्ड्स को रिजुविनेट किया है। इसमें हमने कंस्ट्रक्टेड वेटलैंड और फ्लोटिंग वेटलैंड टेक्नोलॉजी का यूज किया, जो बेसिकली एक नेचर बेस्ड सॉल्यूशन है। इस पॉन्ड को, जैसे हमने उत्तराखंड में जो पॉन्ड को रिजुविनेट किया, उसकी स्टोरेज कैपेसिटी 3 to 4 टाइम्स बढ़ गई। जो ट्रॉफिक स्टेटस था उस पॉन्ड का, वो एनहांस हो गया। वहां का ग्राउंड वाटर रिचार्ज होना शुरू हो गया है। और वाटर बॉडीज जो हैं वो वाटर बॉडी हैज बिकम इफेक्टिव एज इंस्ट्रूमेंट ऑफ वाटर सिक्योरिटी एट विलेज लेवल। तो विलेज लेवल के लिए इस तरह का अगर हम विलेज पॉन्ड्स को रिवाइव करते हैं तो एक बहुत अच्छा सॉल्यूशन होगा। ये पॉन्ड की जो मैं बात कर रहा हूँ उत्तराखंड में, अगर आप लेफ्ट में देखें तो ये इनिशियल कंडीशन थी, और फाइनली आप बिल्कुल राइट में लास्ट में देखें तो ये रिवाइवल के बाद की सिचुएशन है। ये आप देखें या ऊपर कॉर्नर में, ये उसमें से वीड्स निकाले जा रहे हैं। वीड निकालने के बाद ये पॉन्ड क्लियर हो गया। उसके बाद ये कंस्ट्रक्टेड वेटलैंड की टेक्नोलॉजी लगा रहे हैं। और फाइनली आप ये देखें, जो ये बॉटम लेफ्ट में 2 फोटोज हैं, ये फाइनल शेप है। और पानी भी आप देख रहे हैं कि इनलेट का पानी और जो आउटलेट का पानी है उसमें कितना डिफरेंस है। डेटा भी हमने जो कुछ कलेक्ट किया है तो उससे BOD और DO इन सब में इम्प्रूवमेंट पता चला है। इसी तरह से प्रोटेक्शन कंजर्वेशन ऑफ वाटर बॉडीज के लिए IWRM प्लान भी डिस्ट्रिक्ट लेवल पर बनाया गया था बुंदेलखंड के एरिया में। उस तरह का प्लान हर डिस्ट्रिक्ट में हम प्लान कर सकते हैं। भारत सरकार के 2 बहुत मेजर प्रोग्राम्स हैं जो इस समय चल रहे हैं वाटर सिक्योरिटी के लिए। जल शक्ति अभियान, जिसमें वो जो वाटर स्ट्रेस डिस्ट्रिक्ट्स हैं उसमें जो डार्क ब्लॉक्स थे या ग्रे ब्लॉक्स थे, वहां पर वाटर कंजर्वेशन, वाटरशेड डेवलपमेंट, एफॉरेस्टेशन और वाटर बॉडीज का रेनोवेशन, इन सब कंपोनेंट्स को लेकर जल शक्ति अभियान पिछले साल 2019 में शुरू किया गया था। वो अभी भी चालू होगा। और एक नया प्रोग्राम जो भारत सरकार का आया है, जल जीवन मिशन, हर घर को जल, उसमें सन 2024 तक हर हाउस होल्ड को वाटर सप्लाई, पाइप्ड वाटर सप्लाई देने का प्लान है। तो ये एक बहुत एम्बिशियस प्लान है, जो इसमें बहुत तेजी से काम भी इस समय हो रहा है। ये सब तो था वाटर सिक्योरिटी के बारे में। दूसरी जो एक नया कॉन्सेप्ट एटलीस्ट इंडिया के लिए मैं बोल सकता हूँ, एनवायरमेंटल कैरिंग कैपेसिटी। क्योंकि हम अगर देखें तो हिल्स में जो डेवलपमेंट है वो काफी कुछ अनप्लान्ड रहता है। अगर हम वहां के संसाधनों को, पर्यावरण को और इकोसिस्टम को ध्यान में नहीं रखते हुए डेवलपमेंट करेंगे तो वो काफी नुकसानदेह होगा। और इस कैपेसिटी को, कि वहां उस क्षेत्र की कैरिंग कैपेसिटी कितनी है, जो वहां के रिसोर्सेज हैं, जो वहां का एनवायरनमेंट है, जो वहां का इकोसिस्टम है, वो कितना लोड डेवलपमेंट का ले सकता है, उसको कैरिंग कैपेसिटी के टर्म्स में डिफाइन किया जाता है। और ये जो एनवायरमेंटल कैरिंग कैपेसिटी है, ये कॉम्बिनेशन है लैंड कैरिंग कैपेसिटी, वाटर रिसोर्स कैरिंग कैपेसिटी और सोशियो इकोनॉमिक कैरिंग कैपेसिटी का। इन तीनों को मिलाकर एनवायरमेंटल कैरिंग कैपेसिटी हम निकाल सकते हैं। और अगर इस कैपेसिटी को ध्यान में रखते हुए हिल्स में डेवलपमेंट के काम किए जाएं तो वो सस्टेनेबल होंगे और पर्यावरण को और एनवायरनमेंट को नुकसान नहीं पहुंचेगा। तो इस तरह का काम भी पहली बार एक PhD थीसिस में गढ़वाल यूनिवर्सिटी से किया एक बच्चे ने। तो उसमें उसने तीनों इंडिकेटर्स को लेकर सोशियो इकोनॉमिक कैरिंग कैपेसिटी निकाला, वाटर रिसोर्स कैरिंग कैपेसिटी निकाला, लैंड कैरिंग कैपेसिटी निकाला और उससे एक कंबाइंड इंडेक्स उसने वर्कआउट किया। जो आप देखें अगर ये 3 जोन में ये वाटरशेड है, कुंजा गढ़ वाटरशेड, मंदाकिनी रिवर का एक छोटा सा वाटरशेड है। वहां पर 3 एलिवेशन जोन है, लो, मिडिल एंड हाई। उन तीनों के लिए उसने अलग अलग एनवायरमेंटल कैरिंग कैपेसिटी इंडेक्स निकाला। तो सबसे कम जो कैपेसिटी इंडेक्स है वो लो जोन में है, उसके बाद मिडिल जोन में है और सबसे हाई एल्टीट्यूड जोन में है। तो इस तरह से अगर हम ये एनवायरमेंटल कैरिंग कैपेसिटी निकाल कर लोकल प्लानर्स को दे दें तो वो उसके अकॉर्डिंगली डेवलपमेंट कुछ प्लान कर सकते हैं। ये जैसे वहाँ के जिस एरिया में उसने बच्चे ने काम किया है वहाँ के कुछ फोटोग्राफ हैं, किस तरह की एग्रीकल्चर लोग कर रहे हैं, किस तरह के लैंड होल्डिंग है, वहाँ वाटर हार्वेस्टिंग की सिचुएशंस क्या है, ये खाल है, ये कुछ स्प्रिंग को हार्वेस्ट कर रहे हैं। तो इस तरह से अगर हम देखें कि फाइनली अंडरस्टैंडिंग रेसिलियंस ऑफ वाटर बॉडीज इज इम्पॉर्टेंट फ्रॉम द पर्सपेक्टिव ऑफ डिजास्टर एंड क्लाइमेट compatible development, and in order to make water resources and food systems future proof from multiple disasters and hazards, we have to build resilience and sustainability into these systems. Resilient water bodies facilitate water security क्योंकि उससे वाटर कंजर्वेशन होगा, ग्राउंड वाटर रिचार्ज होगा, फ्लड मॉडरेशन होगा और ओवरऑल इकोसिस्टम इंप्रूवमेंट होगा। तो assessment of water security and environmental carrying capacity is vital for sustainable development planning in hilly regions. और जो भारत सरकार की जैसे मैंने बताया स्कीम्स हैं, जल शक्ति अभियान और जल जीवन मिशन, वो इस को अचीव करने में, वाटर सिक्योरिटी को अचीव करने में और डिजास्टर प्रूफिंग करने में काफी मददगार होंगी। फाइनली वी कैन से दैट आज हिमालय दिवस के अवसर पर हम कह सकते हैं कि हिमालय को क्या चाहिए? Perennial springs and streams, good crops, good forest covers, clean environment, good health, education for all, and ultimately better economy. यही सब है जिसके लिए हम सभी हाइड्रोलॉजिस्ट और वाटर साइंटिस्ट इसमें काम कर रहे हैं और अपना योगदान दे रहे हैं। थैंक यू, धन्यवाद।
Thank you, Dr. Vikas Goyal, for providing a largest perspective and roadmap for the future research activities in this region. As we all know that Himalaya is very large, covers a very large area and complex issues. And whatever effort which we make maybe sometimes feel insufficient to achieve the goals which we are aiming at. But on this day, we rededicate ourselves for achieving that larger goal. And there are a number of agencies which full-fledgedly working on and funding these activities in the Himalayan region, which includes our own ministry, Jal Shakti, Ministry of Department of Science and Technology is funding projects through NMC projects. Ministry of Environment and Forest and Climate Change is funding through NMHS project. Science Engineering Research Board, MOEs, and NIH have projects from all these agencies. And I sincerely thank these agencies for funding projects in NIH for achieving these goals. And I also like to thank our director, Dr. J.V. Tyagi, for allowing this seminar and blessing this seminar to webinar to happen on this Himalayan Day. And I thank Deepa Chalis Gonger, Head Computer Division, for making arrangements for this webinar and live streaming in Facebook. And I thank the employees working in this division wholeheartedly. And I thank all the presenters for making their point in this on this webinar and bringing in new perspective and new ideas which is emerging from the research from our NIH. And I hope that these insights which the various agencies are developing knowledge generation in this area will certainly help in better adaptive strategies for the people of the mountains. They are in dire strait of these calamities and lack of water availability in the high reaches. And they really need our help to achieve, sustain their livelihood and have a better life. And in the end, I thank all of you who have joined in the webinar and listened to the presentations patiently. And also thank all of those who are watching us through Facebook live streaming. And thank you very much for all. And we will again rededicate ourselves for the cause of Himalayas and the sustainable development in the Himalayan region. With this, I close this webinar. Thank you all.